Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss some of the most fundamental relational algebra operations. We will discuss about the select operation, the project operation, rename, union, the Cartesian product, and all examples of these operations. The relational algebra is basically dealt with all the relational part and the database systems of that model. When we talk about a relational model, we have to consider all the relationships among the tables, the tuples, and also the attributes of the table. Now the relational algebra handles with the union, Cartesian product, and then select and project particular predicate on that tables. So first we will discuss about the select operation. The select operation select a particular attribute on a table based on some predicate. The predicate should be given with the select operation followed by a brace start and then enclosed with the table name or the relation name. Let's see how to do that. Now, let's look at this relation. This relation is consisting of the branch name, the customer name of that bank branch, their balance, and the account type. The account type may be of savings or of loan. Now we will perform the select operations on this relation to first fetch that whoever the customer having their account in the branch teller will give the output. So first we have to select according to the predicate that the branch name is equals to teller, and after that we have to give the relation name so that we can select all the customer names and their account balance and account type as a result. See, here we are representing the select operation with the Greek letter sigma. Now sigma followed by the branch name equals to teller, that is the predicate for this operation, and the relation name which I have given here loan. So now as a result we will have Perry, John, Watson, Mary eliminated, and we will have the teller Jacob because Perry Smith will also get eliminated. So my result will be So this is the very first and basic select operation on the relation loan. Now this much selection is not readily available and we don't use it that much. So first we need to see that where we can use this select operation. By selecting, we are meaning that we are selecting it for a purpose. Now to solve a purpose, we need to fetch the data and put it in another relation or another operation. Say for example, we select this amount of this Jacob $30,000 and then put it in another operation which count and summation of given the Jacob's account balance. So by that we can use the select operation properly. Now we will see more examples to enhance that what is the basic use of select operations in a relational algebra. Now we are using another more query or predicate on the select operation that we should fetch the balance and name and branch name of a particular person who is having the balance greater than 40,000. So now how can we write that? By writing this, we can fetch all the details of the persons who have their branch name, the name of the person, the balance and the account type who has a balance more than 40,000. So now we will have some result based on this operation. Now we may have conjunct these two operation predicate into a single one, and we can do this with a AND operation. Now this AND operation here we are mentioning has joined this two predicated into a single select operation on the relation loan, so that we can have the result of the persons who have their bank account in branch teller as well as has their balance greater than $40,000. So in this way we can join the predicates of the select operation, and that is the basic select operation that can be performed on a relation. Now we will move further. Our next type of operation is project operation. Now we have to distinguish between the select and project operation. Whenever we're talking about select operation, we are meaning that we are selecting it for a purpose, to solve a purpose, either for counting the number of persons or for use that result to give another result or produce another result. Now the project operation is simply to list all the values or attributes of a relation based on some predicate. Now, whenever we are using a project operation, its fundamental task is to display or list the values depending on the predicate. So, the project operation will simply give us that what values is according to that is satisfying the predicate on that relation. So, we will see that how to do the project operation on this relation. Now we are using here another relation, that is loan 1, which we have to relate it with loan department on the loan relation. So here we will have some loan numbers and the branch name where the loan is existing and the available balance on that loan. See here, the loan number is the primary key of this relation, so we can refer it with any projection and selection operation. Now to project in this relation, we need to first fetch and select the attributes that we want to project. Say suppose we want to project the loan number and the available balance based on the branch name. Then we should write by not using any predicate in the projection operation, we are simply displaying only the attribute values that is mentioned in the projection operation on a particular relation that is mentioned here. So for projection, we are using again the Greek letter pi. So pi is followed by the attribute name and then braces start and enclosed with the relation name. Now, suppose the example I have mentioned earlier that I want to fetch the details of loan number and balance of the person who have their account in the branch teller. So to use that, we have to keep it in very carefully that the projection operation cannot have any predicate operation, so that the use of the selection operation. First, we need to select the value using the predicate, and then using the projection operation, we can display or list the projected values. So how to do that, I will show you. See here, I have merged the projection operation with the select operation. So to project the value, we need to first select it with the selection operation with the relation, and then with the result of this relation, we can use it in the projection operation. So the innermost of this relationship operation gives us the basic result, and the outermost gives us the actual output or listing of data based on the selection operation. So that is the merging of projection and selection. So we will see more example to enhance this example. Now, this is the merging or the composition of selection and projection operation. So our next example will be on the union operation. Say for an example, we have loan 1 here, and we have previously a loan relation which have the branch name, the customer name, the account balance and the account type. So for the loan relation, we can signifyly say that the primary key consists of all the 4 attributes inside the relation. So it should have the customer name, branch name, account name and account type. No individual attribute can be defined as a primary key because it cannot provide the uniqueness for the relation loan. Here we can say that the loan number is obviously unique for each of the account and can be a primary key of loan 1 as well as a candidate and super key. So we are combining this loan 1 and loan using a union operator. So the union operator actually joins two relations based on some predicates. So now we will consider our example above again and see how union operator works. Here we are using a union operation. What you are unioning? This customer name of the loan relation and the branch name of the loan 1 relation. See here, all the values will be distinct as the branch name cannot be equal to the customer name obviously. So this customer name and branch name cannot get joined together using a union operator. It will give us a valid output, but it will be not logical to have such result. So the first two things that we have to keep in mind while doing the union operation is, first, the two columns or the attributes we are choosing for joining the tables or the relation should have exactly the same number of values. And secondly, the first column of the first relation must match with the second column or the column we are joining with the second relation. So here we can match the branch name of loan 1 with the branch name of loan relation. Other than that, there will be a problem because it will be not logical enough to have that much result. So we can join this using a union operation of branch name projecting with the projection of the branch name in loan 1. Thus, if there is any duplicate value, that will be eliminated and we have the result of the distinct values. Let us see that how to do that. So this is our projected operation now. So there is a union operation, so obviously it will get joined. If we can recall that the branch name of the loan relation has exactly in the order of the branch name Perry, Taylor, Watson. Now here we can see that Taylor is first and Perry is second. But as this projection operation comes before the loan 1 operation, so obviously the ordering will be done on behalf of the first relation that is used for the projection operation. And next it will be joined with the second relation projection operation, eliminating the duplicated or repeated values. See, only one Perry, one Taylor and one Watson is our result, not all the list of Perry, Taylor, 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 Watson, Perry. So that is the benefit of using the union operation. Apparently, it may have seemed like a discrimination, but we have to rectify it using a more enhancive operation, that is a set difference operation. The set difference operation does exactly the opposite of the union operation. Suppose if I am differencing or subtracting the values of one column of a relation with another column of another relation, or it may have done that only one column of one relation is get subtracted from another column of the same relation. So we will do that again with our examples above, lone and lone one relation. Now again we are using a compositional operation that has two projection operation. So here we can see that the branch name of lone we are projecting, and we are using the set difference operation that is represented by a minus sign along with the projection operation on a lone one of branch name. So on lone department or the relation we have the branch name Perry, Taylor and Watson, and on lone one department we have the branch name of Taylor and Perry. So as a result, subtracting the result from of lone 1 to lone 2, we can have the actual result only the Perry, that is not mentioned in lone 1 but has mentioned in lone. So the basic result is the subtracted value or the value that is not present in the first relation but as present in the second relation. So here our result will be Watson for this query using the relation and the values. The next type of operation we will perform on the relation is a Cartesian product operation. Whenever we are performing a Cartesian product operation, we can have all the combinations of all the attributes, all the relations that we are joining. Now here we will join obviously the relation lone with lone 1. So first we describe the lone and lone 1 relation. Here we can use the referential integrity of having a foreign key branch name that is the primary key or a part of the primary key in the loan account. Now we will perform the Cartesian product operation on this two relation, and let's see that what is the result of this operation. So we are Cartesian producting of this two relation loan and loan 1, and then projecting the values of the branch name, the customer name and the balance. See here the branch name, customer name and balance are all the attributes of a loan relation, but only the branch name is unbalanced at the relation of a loan 1. So it will be all merged together to produce our desired result, and let's see what will be the result. The left relation that is present in the Cartesian product for here, which is loan, will have the first preference and will be listed first of all the values that is present in the loan relation. First all the values are printed. Now the loan val will be multiplied with this one to have our desired result. But we don't have the customer name in our loan val relation. So this field will be left blank while we are listing the loan 1 relation in the desired result. So it will look like this. Now see, we are having a multiplied value of loan relation and loan 1 relation as our output of the operation. Now, why should we do that by replicating all the values again and again? There is a purpose for doing that. We can choose only the predicate values among this result. Say suppose we have used a select operation with the predicate that branch name equals to Perry. So we will have only the result from this output that has a branch name Perry. So let's look at that what will be the result of doing so. As I have mentioned earlier that the innermost relation or operation will be occupied first. So here first the Cartesian product will be done on lone and lone one relation. Then the selection will be done on the branch name equals to Perry predicate, and then it will be projected on these three attributes of the result. So now our output will be sorted down by So we will have only this Perry branch name along with the customer name John and Smith, and here we will have no customer name as our result. So this is the basic difference of a Cartesian product and a composite operation on a Cartesian product of projection and selection operation. Now we will move to our next part of the operation that is also an important basic fundamental operations of relational algebra, that is rename operation. Often